Hey everyone, welcome to the Gravwell demo portion. I'm of course Paul Asadorian, and I'm here with my good friend Corey Thuen. Corey, I counted. You've this year appeared 7 times across the Security Weekly
That's
network.
that's a lucky number.
It
We
is,
can't
it
do
is a
any
lucky
more.
number. That's it. We're capped at 7.
We gotta stop. Yep, we gotta stop there. I don't want to jinx it. Yeah,
We just won't
exactly.
count this
No,
one.
it's always good.
Yeah, it's awesome.
Always good to come
So
chat.
what is your title? I know you're co-founder at Gravwell. Do you have an official? Are you CEO? You're CTO?
CEO is the official corporate title. So yeah, I'm doing all those things as well. But the passion still sits in the cybersecurity trenches, and so it's always fun to walk through and create sort of demo or environments like we're gonna do today, because that's where my background's at. That's where I come from, even though I do a lot more high level stuff these days. But it's still, passion, and it's in the blood, as it were.
Absolutely. Yeah, this is exciting. So why don't we just jump right into it, Corey, and we'll go through a demo, and I'll just ask questions of what I think is interesting or questions that come to mind as you're kind of going through your demo.
Yeah, absolutely. So one of the things that I like to kind of always repeat to myself, sort of just to get myself in a frame of mind when I'm talking about this, is my 2 favorite quotes about cybersecurity are from Spaff. A system is good if it does what it's supposed to do, and secure if it doesn't do anything else. And then Schneier's, of course, security is a process, not a product. And those 2 things, I think, are pretty important when we are kind of going through and talking cybersecurity. So just for the benefit of anybody watching this, I know we have knowledge of each other. We're just chums hanging out. But before I got into Gravwell, I was a vulnerability researcher at IOActive, Digital Bond, and Idaho National Laboratory. And so that was vulnerability research, a little different than like pen testing. Vuln research is focused on finding the O days. Versus pen testing, which is more about environments and everything. And then now I co-founded Gravwell, which is a structure on read data lake. And it's super great for hunting through data and doing threat hunting and figuring stuff out. And sort of the reason or the why behind why we left the red team world and got into this is I really do believe that cybersecurity should use our unique position, because we kind of are the central brain. Like a bunch of data comes into the spot for use in cybersecurity, and we can make systems good and secure at the same time by investing in our people and our processes, because every organization is unique, and that's the whole point of security being a process. And data is better together. So that's kind of why we went through and did that. But really, kind of to kick on why the talk is titled this way, why the abstract is that way, is this tweet was just, I think it was last week or something, came up sort of on a discussion about red teamers should be aware of what the blue team sees in the events, or what kind of events they create when they conduct activity. But particularly the last tweet in the chain was a surprise in how much this resonated with people in terms of this kind of should be sort of a one-on-one red team thing. But I think we have historically had a lot of separation. So it's really cool to see the joining of that together and being more of a purple team. And we've got more products that are coming out, more tools that create more of a purple team style environment. And our motto is data is better together, and people are not really any different when we all work together to get for the same mission. So this is kind of what put a bug in my butt to want to talk about this from a little bit more of a red team perspective. And so what we're going to do here is we're going to walk through a threat hunt, and obviously it's a little contrived. I mean, this is an environment that we created and everything that I made and I've been playing with, but all of the sort of individual pieces are definitely things that have happened in a real environment. And so that's what we're going to walk through with you here, using Gravwell to look at the events, because that's our jam, is we sort through a whole bunch of events at a time.
And so Corey, to think about the evolution when you think about being a pen tester, as I was a pen tester for quite some time as well. And, you start out, I think in the early days, you were like, no one really noticed you hardly at all. And you didn't really work hard to kind of cover your tracks. And then, I think somewhere in the middle, you're like, well, yeah, I did get in and I probably left some logs and evidence behind, but no one noticed, to the purple teaming more aspect of it today, where we are interested in what evidence I would leave behind, what that evidence is, how the blue teams discover that evidence and working together. I think that's a great evolution of this process.
Yeah, exactly. And really, sort of as we'll hit in a little bit, threat hunting, kind of like vulnerability research, is almost more of an art than a science, because you're like when you're reverse engineering protocols and stuff, it's you're having to. There's a lot of art in it, which is interesting. So I will try and get the screen share going here. We'll start with. I guess these slides. So the tweet that I was mentioning is this one here from Prologue, or however we say it. But if we get into the demo, let me just throw up a diagram of the environment here, just so you get an idea about what we're looking at. So basically, I had a span port with a bunch of sensors, because that's an important thing for us. GravWell is not a sensor. Although, as we're doing the threat hunt, you'll definitely see some of that aspect or bleed over. But we want data from Zeek. We want it from IDSs, from firewalls, from all this these different sensors. That's the data that comes into us, and then we put all in one place in the data lake and make it easy to search it and everything else. And so, also in this environment, we've got. No, go ahead.
I'm sorry. That's what I love about GravWell is I don't say you don't care where it comes from, but it doesn't matter where it comes from. I think more accurately is the statement.
Yeah, that's the big benefit of structure on read, which is the big difference between like us and Elastic or certainly your traditional SIM. There, you're kind of forcing the data to fit a mold, but in GravWell, we take the data as is and work off of it that way. And so there are a lot of advantages, which you'll see as we get in there, and trade-offs for the different approaches. But then also in the environment, we've got Samba server and then some Windows hosts doing some stuff. And if we're interested in how this starts up, like all of it is pretty much Docker containers. The only thing is the Windows machines that require installing Sysmon and our ingester. So there is a small agent that sits on the Windows machines, and all it does is look at the Windows event log and ship it out with a little bit of caching that you can optionally turn on in order to make sure that you preserve events. But the events are shipped out in time as they happen, as soon as possible. So,
which is important.
Yes, especially if there's an attacker presence there. So let's talk about the activity prologue. So here's what's going on with this scenario here. So we just made a little malware, example malware. It's just a dumb piece of code that what it does is it port scans the local subnets and it exfiltrates those port scan results over DNS in an super secret encrypted coded format. I say that facetiously, of course, and then it copies itself to Windows file shares and renames the copy to an enticing file name like holidaybonuses.pdf.exe to see if anybody clicks it on, right? So in the scenario, a user downloaded this from the internet, ran it, which then spread to our Samba share, and then it was executed by another user on the network who's a consumer of that share as well. So that's pretty much the extent of what we're going to be looking at here, but we're going to look at a few different data sources and how these things happened in order to get there. So one of the things I recently did a blog post on the guest post on the IOActive blog called "Hiding in the Noise," which was sort of about weak signals versus strong signals and using weak signals for indicators. So an example of a weak signal is an increased number of reset packets on a network. You're not going to treat that as something strong, because if you try to take action every time that happened, you'd be going insane. It's too much stuff. But if you can line that up and correlate it with other weak signals, then you can kind of fuse that into a strong signal, and then it gets interesting. And so that's kind of what we're going to start off with here in what we're doing. So just in terms of a basic aggregate, so within GravWell, again, everything is in its raw form. We are structure on read, so everything is driven by the query language. But as you'll see, when I start clicking around in dashboards and moving rapidly, it's easy to navigate. But under the hood, everything is driven by the query language, which means that it's extensible and it's powerful, and you can easily tailor it to any unique need in your given activity, which will become super important when we get to the DNS. So like if we did something like this, where we just are plotting on a graph the count of new connections that are coming out of a system, it's not really that interesting. But we can one of the things that Gravel kind of tries to do is commoditize data science a little bit and make it so that with a query language, instead of like a Python notebook or some complicated code or anything, you can do more interesting things. So it doesn't really matter what the searches are for this instance. Typically in an organization, a threat hunter would be familiar with the search syntax, and then they would go through this versus more of a junior analyst who's going to spend more time clicking, I suppose you would say. But for purposes of this, I'll just explain what the query is instead of diving into it, because we're not focused on Gravel so much as we're focused on the signals that are being generated. And so what I did with this query is I bucketed these events into 5-minute buckets to kind of clean up the signal a little bit, get us where we're at. And then what I can do sort of further from there, which really gets into the statistical stuff and sort of the obvious next step is applications of ML and AI directly in pipeline. So the little tweak you saw me do with the search there was changing it so that we're going to add a noise floor. And we're going to filter out anything that's less than 2 standard deviations from the average. And this average is dynamically computed for this time range. And so you've got kind of a rolling average for what's happening, rather than creating a baseline once and then having that not applicable, in the next week. And when we do that, now we can take our weak signal and we start to clean it up a little bit. And now we've got a couple, I guess I would call them medium signals. We've eliminated some noise to see like, okay, this is a weak signal. We've got 2 systems here who have done an abnormal amount of activity, of new network connections that are from them. And so we could also perhaps...
I was just going to say, you dynamically were able to find those outliers, but with your query. Yeah. I mean, essentially looking for is outliers, but I mean, it's an easy thing to say, but applying the kind of data science and methodology there, you were very quickly able to find those outliers. Yeah,
that's true. We kind of hand waved over that but essentially, so this is a new feature in the next version of Gravel 4.1, which I'm on beta for right now, but comes out very soon. And it includes compound queries. So we already have data fusion where you can put 2 different data sources in the same pipeline. But now we have compound queries where you can run 2 searches in series. And this is one of the great use cases for that, in that we can run a search to establish our baseline over this time range. And then we run another search over the same time range to do the filtering and the statistical pullouts there. And so that's what lets us see that, 10.07 and 10.016 are above the noise floor in terms of abnormal number of outgoing connections. And you defined the noise floor basically dynamically with your queries, whereas I feel like in other systems, that noise floor is kind of already defined for you, which doesn't really represent reality. Yeah, it's not the average noise floor of top 50 organizations in the world or whatever. No, this noise floor is built with your data, which is what we encourage. That's the advantage of the data lake versus getting something else. And so that's exactly what we're doing is we're building the average and the standard deviation, and then I'm saying the standard deviation times 2, and then dropping everything that's less than that. So these are 2 standard deviations away from normal, which is cool. So if I wanted to, I could change it to 3 and see, how that affects if I can drop some things out. So in this case, it dropped everything. But that's the kind of the capability to tweak and do that. Yeah. And you can build these queries and share them with the more junior analysts. Yeah, exactly. I mean, for this call, as I'm walking through this with you, like I'm doing a lot of copy pasting, but in reality, you're going to have these in dashboards. You're going to have them clicked up. Exactly. Which we'll get to in just a little tiny bit. But in the beginning, we're doing a little bit more of this style of stuff. So one of the interesting things that we can also do is, so if we can run a search that says, so another weak signal is process whitelisting. And so if I run a search that says, what's every process that's ever been executed? So this is using the Sysmon data, because Sysmon is great for that. It tracks you. It'll tell you every single process that runs. And so if we do that, we can build a whitelist per host in our analytics platform, not relying on the host or any list there. So again, dynamically generated based on your data. And in this instance, if I create this list off of the previous week or maybe the previous 24 hours, and then I come in here and do something where I will search for it using a different, and then I can check against that list, then that's where the new ones come out. And so let me just run that here, although actually I messed up my time frame a little bit. Because what I would want to do, so I'll go in here and let's say I'm going to unlock my time frame. So one of the other new features that's coming now is the ability to lock time frames for within Gravwell. So which is what I've kind of been doing so far, just because I knew where this data was at. But just as we're looking at a small piece of time, you could easily look at anything else. So if I go from the 27th to the 1st, let's say, because we know that the other time frame range is in there, and then I'm just going to artificially filter out stuff that I know is there because it wouldn't have happened beforehand while I was testing, but I wasn't. So forgive my hand waving here as I Wizard of Oz this just a little tiny bit for you. But essentially, so this is going to create the baseline that says a list of every process that's executed, and then I'm going to save that within Gravwell as a resource that I can look up later. And that should have saved that there. And then within this search, I'm going to look that up. And so if I come into this time range here and run the search, that will filter out the noise again. So these are all new processes that have executed within this time range that have never been seen in the 3 days prior. Which, if you've got a lot of systems,
you created your time. You created your timeline from a previous 3 days, and then did your analysis based on that data for a shorter time span.
Yep, exactly. That's what this search does. We're looking from the 27th to the 1st, creating a baseline, and then on the 1st later in the day, we're going to look up that baseline and see who violates this. So this type of thing is you can use this same technique for network whitelisting, process whitelisting, which is a lot more useful in OT, but it can be used for weak signals in IT, and that's exactly what we're doing here. So then we see this list of stuff. There's some System 32 things, which initially I'm going to be like, okay, we'll kind of ignore those first, and then I see these two systems here, totally not malware.exe and holidaybonuses.pdf.exe. So immediately there's going to be some, what's our hypothesis? What's going on here? We can start to generate
I think the system's infected with malware.
Yeah. Okay. But that's an interesting thing because, so with the hypothesis, there is a little bit of that, but it's like, it's a little bit like Fargo, right? You said it's funny looking. And you say, well, how was he funny looking? I don't know. It's just kind of funny looking.
It's just funny looking.
We want to be specific, right? We want to say like on 12.1 at around, 2208, 10.1.6 and 10.1.1 had some never before seen processes and some some unusual network activity. So we can say that the hypothesis is that, totally not malware.exe is in fact malware. And one of the ways that we can check that out is let's just look at our activity for this given host, because we know that 10.0.1.6 showed up in our weak signal previously. And so again, you'd want to kind of automate this, but we're going through a little bit more manually. And 10.0.1.183 is here. I can change this a little bit. But we didn't see that before. So let's start with 10.0.1.6 on our investigation. Right, and we want to look up what's going on here. That was Sysmon data, so perhaps let's go to our Sysmon IP investigator dashboard, set our IP instead of using that, and see what we've got. But let me switch time frames here to where we were. And we can see, so in the Sysmon activity, there's, the dashboard gives us standard dashboardy things, kind of overviews like which users are being, are creating most of the processes, what type of DNS activity was there, as well as a table of the DNS activity. And when we come here and look at that, we see some unusual. So this is where being a human is really nice, because I'm a human and I look at this and I say, yeah, this is not good. Even though it says evil.gravwell.io, even if it didn't say evil, you can look at this. But what's interesting is, so you'd think like, okay, let's create a rule that looks at entropy of DNS, and that's going to pop this out like crazy. Oh, well, those types of rules is a weak signal because there's a lot of noise. I don't know if you ever tried to do something like that, but Google and Apple and Amazon all have very high entropy DNS. That make that a little challenging. So
DNS
there's
is
a certain amount of
entropy-ish kind of protocol.
More so than it should be, right? In theory, but that's kind of a tangent. So, but yeah, exactly. Like this is not cool. There's something going on here. So this is in Sysmon data. What if we take this and open up DNS? So we could do like a who is, but I'm gonna go to the investigation dashboard just for this domain. And interestingly, it does not appear in the Zeek records. And speaking frankly, I don't know why, Paul.
That's interesting.
There are multiple times that I've ran this whole scenario and it does show up. I don't know why. This time when I ran the scenario, it didn't. I honestly don't. Because Zeek is otherwise giving us great data. But I think that's an important point because you don't, this is why you need multiple sources of data. Yeah. Because you don't know when one of your components is going to fail. Something was accidentally off, so now we don't have DNS records for, the last few hours. Like that's not good, especially if you need it for an investigation, which in this case we accidentally did. This was not an intentional piece of the environment here. So that's an important thing to point out.
Yeah, and we like to speculate as to the quality of your sources and if they're going to give you reliable data or not. And we do that based on experience in history. We think that this source will provide this level of reliability, but there's always a variance. And to your point, sometimes things just stop collecting for a lot of different reasons, even though you may have categorized it as a reliable source. It happens all the time.
Yeah. I would not, like, Zeek is really reliable. I've seen really great stuff out of it. But all software has problems, ours included. I'm not going to say that we don't. So yeah, it's interesting. So multiple data sources for the same thing are going to be how you shore up that risk if you're worrying about that on your own internal organization. But from a kind of a hunting perspective, we're going to switch to manual mode. Let's disengage the automatic. And now, so everything we've done so far could have been done in dashboards and clicking and everything without actually using the query syntax. But now we kind of need to, because we're talking about DNS records that, I want more information out of what this exfiltration is doing. So I'm going to use a manual query and I'm going to add in this regex module. So the advantage to how you can craft and structure on read and crafting an analytics pipeline is you can just chain stuff, you can plumb it up and chain it together and go forward from there. So in this example, I'm going to extract these individual pieces from there because I saw that there was some hex goo and then a number and separated by dots and then another number and then evil.gravwell.io. That's the regex that I'm looking at. And so that's what I wanted to extract. And then pull those out into individual pieces. But then, if I'm interested in saying, let's see if we can, this is kind of the reverse engineering side. What if we base 64 decode the hex 1 value? Is this base 64? No, doesn't look like it. What if we just change it into ASCII hex or ASCII text? And then what was binary goo turns out to be just hexlified IP address text. There we're getting a much better idea. Like, hey, this thing's sending out information about our network over DNS.
Was that your fancy encryption scheme you mentioned before?
Yeah, unbreakable, stronger than ROT 13.
Yes.
Exactly.
Hey, Corey,
so
how are we doing on time? I can't actually see the timer, so I just wanted to make sure we were.
I think around 25 minutes.
Okay.
So we'll wrap it up here. Yep, no worries. So one of the things that we've seen, which has been really interesting, is imagine that this was base 64, and I was decoding it, and then let's say it was a packet. I can pipe that into our packet module. If we were doing a TCP over DNS or UDP over DNS, which is absolutely a thing, I can pipe the results of that decode into packet, and then I'm proceeding as if I was looking at raw packets. And all the rest of the dissection, it happens within the pipeline, and the analyst doesn't have to worry about it. So that's really the awesome stuff you can do when it's structure on read like that, because it doesn't have to fit a certain mold. We can roll with it wherever it is.
You can de-encapsulate on the fly. I was just going to say,
exactly.
De-encapsulate on the fly. Yeah, it's awesome.
So then, kind of the final thing that I wanted to point out from there, in terms of a threat hunt perspective, is you probably want to set up some rules and stuff for this. So if I grep through our sysmon logs, I can look for this given hash, which is present in the sysmon information, and look for any file name that's ever had this hash and has been seen by any Windows machine anywhere. And then what I can do is, this is just an example. I mean, you're going to have multiple of these, but I can set that as a property of, I'm going to name this APT Fancy Lumberjack, because this is a new malware, which is kind of an important point that we sort of glossed over in the beginning, was like, this malware is not going to throw any indicators. No antivirus is going to pick this up. No IDS is going to see this, because this is totally custom and it's never been seen before. It's not using, it's not using a toolkit. It doesn't have any known strings in it. And so it's not going to be found. And so we're going to create a rule custom for ourselves that saves this. And then if we wanted to, as an example, let's take a look at our Zeek data. So we created the rule with sysmon, but then we can use this APT Fancy Lumberjack lookup to do this, to say, where do these file names show up within the system based on the file name that we associated with the hash. Because Zeek doesn't have hashes always for a given thing. So, that's the other advantage to having multiple data sources put together to create that data is better together environment, because sysmon will hash everything, but Zeek doesn't necessarily, or some other data source may not. And so you can combine sort of these extra artifacts and put it together, and that's where you end up. And so like this type of rule, then you either set up to alert or connect up to your SOAR, or, whether it's Phantom or Swimlane or something like that, right? And that's where you go from there, from a blue team perspective. So to kind of wrap it around to the beginning, where we talked about why are we talking about this in a red team perspective? Like, as red teams are doing environments, you want to be able to help the blue team to figure out what's going on. Because in these results, we had, there's some MITRE attack techniques that qualify for this. Some of these rules would be kind of put in those buckets. But the interesting part about this is you can't so for all the rules that we just did, you can't just throw that in attack technique 1595 and say that you detect that now. Because that is not true. For this data source, you detect that, which is an important point when you're thinking about MITRE and using that framework. Every data source kind of becomes like, some apply to some pieces, and detection in one doesn't mean that you detect it in other places either, which is an important point as well, which is why security is a process. And I'm excited for the future, because certainly something that we're pushing for, and that is happening, is detection as code. To where the kits that are in Gradwell are Git repositories that can include pre-built searches and scheduled searches and everything, to kind of be more of a detection as code style for how you're deploying. Because blue team needs to manage the process like devs or DevOps manages IT operations. And so I'm excited, just future thinking, how that's going to become more interesting. But
that's really
purple.
Really awesome.
Purple's a great color. We should do more purpling. Have the red team help. The red team has a duty to keep an audit trail and the timeline of activity that they do. I think the red team has a duty to understand unusual network activity that would be caused by their actions, identifying which Windows event IDs are related to your tracks, because that helps everybody to do better remediation. Nobody wants a pen test from some firm that comes in, says, oh, you're owned upside down and sideways. Here's all the stuff that we stole from your machines. Good luck. Because post-mortem is how you actually get value out of red teaming instead of checking a box. And so, appreciate the chance to kind of walk through us. And hopefully people can think about this. If you wanted to use Gravel for this in your home environment or your lab, or at your pen test organization, we've got there's Community Edition, which is available free, up to 2 gigs a day, and then we have licensed tiers beyond that for unlimited data ingestion as well. So
fantastic, great stuff, Corey. And I think a conclusion of this demo will lead folks to a place where they can get more information, like automatically.
That's right. Yep. When we finish this up, everybody's going to be dropped into the Knowledge Center, where you can get handouts as part of this talk. The slides will be there, along with some other material on this type of activity for sure. So hope you enjoy the Knowledge Center, and thanks for hanging out.
Corey, thanks so much.
And then I'll have you go ahead and end that screen share so I can end the webcast.
Oh, yeah, you got to end the screen share.